Let's talk about the theory of continental drift. Why don't we look at a world map? Have you ever seen one of these? Well, of course you've seen one of these. Everyone has seen a map of the world. In fact, you probably first saw a map of the world when you were in kindergarten. And what you may have noticed, similar to so many people before you, is that if you look carefully at the continents, the giant land masses covering about 29% of the Earth, if you look at them carefully, they almost look like puzzle pieces, like they fit together. Especially if you look at certain parts of the world, like the eastern coast of South America and the west coast of Africa, for example. They look like they belong together. Now, I hate to break your hearts, but this is not a groundbreaking discovery. In fact, people have known this for hundreds of years. Most people have just taken it for granted that that's just the way the continents look. But there have been a few brave scientists throughout history who have thought that it must be something more. Let me introduce you to one. This is Alfred Wegener. Alfred Wegener was a German meteorologist. He studied weather. He lived in the late 1800s and early 1900s. And as a weather person, a scientist of the atmosphere, of course, Wegener spent a lot of time looking at maps. And so he noticed this strange shape phenomenon just like you did. The problem is he couldn't get past it. He actually devoted his whole life to it. He came up with a radical theory that suggested that the continents were actually once connected and then somehow ripped apart to where they are today. He came out and he said, "I think the continents are moving." Of course, people thought this was kind of a silly thought to have. How could a continent possibly move? But Wegener really thought that this was the case, and so he devoted his whole career to studying this and coming up with proof of this radical idea. In fact, Wegener didn't just think the continents were moving. He actually believed that there was a time when they were all connected, and they have since drifted apart to their current locations. He even came up with a name for that supercontinent that existed in the past. He called it Pangaea, the supercontinent that he believed existed about 250 million years ago. Pangaea, or Pangaea, is actually an appropriate name. It's a Greek term that means entire Earth, or all Earth. So if you think about it, when all the continents were together, if Wegener is correct, it would make sense to call that landmass Pangaea, or Pangaea. Here's what he thought it looked like. You can see within this diagram the modern-day continents of North America, Africa, South America, Antarctica, India, etc. But they don't look quite the same way they do today. And of course, they're in totally different positions, all connected into this one supercontinent. Now, people thought Wegener was a little bit nutty. And so he knew that if he was going to make any headway with this idea, he had to come up with evidence. And so we're going to take a look at 4 pieces of evidence that Wegener put together to prove to the public that the continents had in fact drifted. Let's take a look at his first piece of evidence. We'll go back to this map here. Now, the first piece of evidence we've actually already discussed. It's simply the observation that the continents appear to fit together. As simple as that. Wegener didn't believe that this could be simply a coincidence. He feels like there's no possible way the continents would have this appearance just randomly. And so this becomes evidence number 1. We will call it the apparent fit of the continents, the fact that they look like they fit together. And just to expand on that a little bit, essentially the coastlines of the continents appear to fit together, kind of like the pieces of a puzzle. But that's not enough. So Wegener went back to the drawing board. He dug through piles of books and libraries and became quite interested in fossils and other evidence of prehistoric life. In fact, Wegener became particularly interested in that guy who just swam across the screen, the Mesosaurus. Now let me tell you about the Mesosaurus. This is an ancient reptile that lived only in shallow fresh water. What's interesting, though, is that there's only 2 places in the world where we find fossils of this freshwater creature. One place is the eastern coast of South America, and the other is the western coast of Africa. Now, there's a couple possible solutions for this. Now, either the Mesosaurus was living on one of these continents and somehow learned how to fly across the Atlantic Ocean to inhabit the other side of the other continent. But that's not likely. The Mesosaurus certainly could not fly. And we know the Mesosaurus couldn't have swam across. The distance is just too great, and they can't survive in salt water. So that's out of the question. Maybe the water was frozen and he walked across? Well, that's a possibility, but there's really no evidence to support that. And so what Wegener said is that while the Mesosaurus roamed the land, Africa and South America were connected, and they were able to freely walk across the land masses. And then after going extinct, the land masses were torn apart and separated, carrying some of the fossils to what would become South America and some to what would become Africa. Interestingly, Wegener looked into this and found that there were other organisms that lived in the past that had similar fossil distributions. Cynonathus, Lystrosaurus, and Glossoteris being amongst the more notable ones. These fossils all have these very unique distribution patterns that suggest that the continents were once together. And in fact, if you reassemble the continents and map out the locations of these fossils, they line up perfectly. So that's our evidence number 2. We call it fossil correlation. Correlation simply means matching up. So matching up fossils on either side of the ocean. To summarize, identical fossils have been